There we go. Okay, so we're going to talk about a new feature in 2019 called Accelerated Database Recovery. This is a database level setting, and it is available in both Standard and Enterprise Edition. So no matter what tier you're running at, you can enable this at the database level. What it does is it changes the way that SQL Server handles rollbacks. And by doing this, it optimizes transaction log processing, which increases the speed of transactional processing, and it also increases the performance during a rollback. And it also has the knock-on effect of reducing transaction log size and log write weights. And I'll talk through some of those things as I get into the demos. The way that this works is when you enable accelerated database recovery on a database, it creates a table in that database called a persistent version store. And then when you make changes to that database, it writes the previous version of the row that has been modified. If it's been deleted or updated, it will write the previous version into the persistent version store. And generally, if you have a long-running transaction and that transaction is rolling back, if it is a very large transaction, you can get locking at the object level. And when you have locking at the object level, anything that's trying to access those records that are being rolled back will be blocked. With accelerated database recovery, you can kind of think of it as a pass-through. If somebody comes to hit one of those records that's being rolled back, instead of going to the data file, it will go to the persisted version store. So it basically removes that blocking activity or blocking behavior of rollback. So what I'm going to do is I've got a database called ADRDB, and as I said, it's a database level setting. So in SYS databases in 2019, there is accelerated database recovery on flag. Run this, you can see my database, it is off, it is set to 0. And then what I'm going to do is I am going to delete rows out of a table. I have a table called Black Sabbath. We're going to imagine it's 1979 during the Never Say Die sessions. They've just kicked Ozzy out of the band. So I am going to delete all of the values with the last name of Osborne from the table. And after I do that, I am going to grab all of the log records associated with that with an operation type of delete rows. So that's going to show me all of the log records in the transaction log that are deletes. And then I am going to grab all of the records with a description of compensation. So the way that the rollback works is for every forward operation, in this case a delete, it is going to generate a compensation record, and for a delete, that compensation is an insert. For an update, the compensation record is another update, and for an insert, the compensation record is a delete. So I'm going to run this, and it'll take about 10 seconds. And once it completes, we will see the results. Almost there. Okay, so you can see that I have 250,000 deletes, and with the rollback, and actually I didn't mention that, I'm rolling back the transaction here in the middle, I get 250,000 inserts. And as I said, this ran for about 14 seconds, and that's a combination of the time it took to execute the deletes going forward and then the rollback going the other way. So for those 14 seconds, anyone trying to access any of the rows with the last name of Osborne would be blocked. That doesn't seem like a long amount of time, but this is a pretty trivial example. I have seen instances where, actually multiple times in my career, I've gotten a call from an application area at, say, 4 o'clock on a Thursday, and they say, 8 a.m. this morning, we kicked off a delete from this table, and it's still running. Can you kill it? Now, if you kill a process, it has the same effect as a rollback. It will roll back any activity that has gone forward, and that can take a long time. And during that time, if they've deleted a large number of rows out of a table, then any other activity that's trying to hit that table can be blocked. So that's how it works prior to accelerated database recovery. I am now going to enable accelerated database recovery, and it is an alter database statement. You just turn it on, and just to show you I've got nothing up my sleeve, it is now set to 1. I am now going to delete those same rows from the table with accelerated database recovery on. And in this case, I'm going to check the transaction log for any operations that are LOP delete rows or insert rows. So we'll see what it does. Should run for about 10 seconds or so. All right. So you can see that I have the 250,000 delete rows, which I would expect to see, but instead of the compensation records to insert those 250,000 rows back, what I've got is 8,000 or 85,704 inserts to the persistent version store table. I don't know why the numbers are different. I've talked to people at Microsoft and have not been able to get an answer, and I haven't had the chance to dig far enough into the internals to figure out why that is, why it's doing it the way it is. It's batching those persistent version stores somehow. Don't know if it has something to do with the fact that all of my values are the same. I've got an identity column in this table, but the majority of the text data is the same. So that may have something to do with it. I've got to play around with it some more. So that is how that behavior changes. Rather than rolling those back one at a time, when I run that delete, and this happens when I run the delete statement, it updates that persisted version store. And then while the rollback is happening, which I'll do here, any transactions that are coming in, as I said before, are going to, looking for a record that with the last name of Osborne, is going to hit the persisted version store, and they won't have to wait for that rollback to complete. So let me run this, and this is going to roll back that transaction, and then it's going to pull back all of the log records that have been written as a result of the rollback. And then finally, it's going to look for anything with a compensation record. So kick this off. Once again, about 10 to 15 seconds. Okay, so when I run that query to pull back everything that is has run as part of the rollback, I get the last record in the log prior to that rollback running. So that's what this row 1 is. And then I have this row 2, and this is just an abort transaction. So when I start the delete, I get what's an LOP begin exact operation, and that is my begin of my transaction. And then if I commit, I'll get an LOP commit transaction. The abort transaction indicates that the transaction has been rolled back. So I'm only getting one record in my log for that rollback, where prior to that, I was getting the 250,000 inserts along with whatever else would generate as a part of that rollback activity. And then I don't see any compensation records because the persistent version store is there to show me the data the way it looked prior to the delete. Couple of other things that this does for you is the way that the transaction log works is it is divided into virtual units or logical units called virtual log files. And any virtual log file that contains log records that SQL Server needs, and that could be for a transaction that is not committed and may roll back. If your database is in full recovery, it could be a database that has not had a log backup run. Those VLFs are active and cannot be freed. If you're running transaction logs on a cadence, you can free those VLFs and you can reuse that space. Because of the way that accelerated database recovery affects that behavior, this will reduce the size of your transaction log files, and it will also reduce your log write weights. And a log write weight is you have a transaction that is writing to the log, and that can cause blocking and waiting, and it will reduce that as well. You might ask what the catch is here. The only thing that I have seen that could be considered a catch is because you're creating this persisted version store table in the database, that table takes up space. But from what I have seen, the amount of space that is added by the persistent version store is about 10% of the space that you share or you save with your log file. And according to my clock, I've got about 5 seconds left. So that's what I've got. And then my contact info is here. My Twitter handle is ScreebyDBA, and my email address is screebydba@gmail.com. And I can't dismiss my timer. So that is what I've got.